Hello again, guys. Today we're going to look at doing operations with scientific notation. So if you're still a little confused with scientific notation, I suggest you stop right now, go back, rewatch the other video, make sure that you've got that before we try to move on to operations using scientific notation. So basically what I'm saying is I want to take my scientific notation number, multiply it by another number. So here I've given you an example, 2 times 7.5 times 10 to the third. So if you'll recall, back when we talked about properties, the grouping of the factors does not matter. The associative property tells me it doesn't matter what order I multiply these in. All right? The thing we want to remember is we still want to keep our answers in scientific notation. So since the grouping doesn't matter, what I'm going to do is I'm going to multiply my first 2 set of factors first. So I'm going to ignore that power of 10 right now. I'm just going to multiply 2 times 7.5. When I do that, I get 15. What you'll notice is that 15 is not in scientific notation because it's greater than 10. So what I want to do is I want to take that, I want to rewrite it in scientific notation. 15 in scientific notation means it's 1.5 times 10 to the first. I would have to move my decimal over 1 spot. Okay? So we're going to rewrite that in scientific notation. Then, if you'll recall, I still have my other exponent of 10 up here. So then what I'm going to do is I'm going to take my 2 powers of 10. Using my rules for multiplying exponents, I'm going to combine those. So I have a 10 to the first times 10 to the third, which gives me 10 to the fourth. So now I'm just going to continue to keep that written. I'm not going to do this math out. I'm going to keep this written as the product of the 2 factors because I want to keep it in scientific notation. So I have the 1.5 times 10 to the fourth. All right. Now the other thing we could do is we could calculate what the 7.5 times 10 to the third was in standard form, multiply it by 2, and then convert it back. But this is just a little quicker. It's a different way to do it. So we're going to do, using the properties that we learned, we're going to use the associative property to group together certain things to make our multiplications easier. So I want to take a look at a couple that are just doing multiplication. Then we'll move on and we'll take a look at it using division. So again, if you'll recall, my associative property tells me it doesn't matter what order I multiply things in or how I group them. So I'm going to group my first 2 factors together. And I'm going to cheat and use my calculator here just to save us a little time. So when I multiply 3.98 times 4, I wind up with 15.92. Now this is not in scientific notation because this is greater than 10. So I'm going to take it, I'm going to convert it into scientific notation. Again, if you're confused with that, go back, rewatch that first video before this. Well, if I move my decimal over here, 1 place, then I have a number between 1 and 10, and that means I've moved it 1 place, so 10 to the first. Now I'm going to look at this, I'm going to take my 10 to the first, I'm going to multiply it by my 10 to the fifth, which was in my original problem. So I have the same base. I add my exponents. -5 plus 1 gives me -4. And I'm going to keep my number that I've changed over here, 1.592 times 10 to the -4. All right, here what you'll notice is I wrote the number, we're multiplying it at the back of it. Doesn't make a difference. I want to look at my 2 numbers that are not exponents and multiply those together. So 4.1 times 9 gives me 36.9. All right, you'll notice that's not in scientific notation because 36 is greater than 10. So we want to rewrite this in scientific notation. So if I move my decimal over here, 1 spot, I get 3.69 times 10 to the first. That's what it would look like in scientific notation. Now I'm going to take my other power of 10, and I'm going to multiply my 2 powers of 10 together. Again, remember, my base is 10. That stays the same. I add my exponents. 3 plus 1 is 4. So it's 3.69 times 10 to the fourth. Keeping our answer in scientific notation. So again, here, take a look. I've got 0.9 times 8. Actually, could have done that one in my head. This is why we don't use calculators. You just start relying on them too much and you stop using your brain power. What you'll notice, 7.2, this already fits the rules for my first number. This is between 1 and 10. So I don't need to change it at all. All I need to do is take my power of 10 and bring it down here. So this is 7.2 times 10 to the 9th. That one was nice and easy because I didn't have to convert this number. It already fit into what I needed it to be for scientific notation. All right, taking a look at the last one. Again, remember, using my associative property, I'm going to multiply these two factors. 6 times 5.1 gives me 30.6. 30.6 is not in scientific notation. We want to make it into scientific notation, which means I need to move my decimal over one spot. I get 3.06. I moved it one spot times 10 to the first. Then I'm going to take my 10 to the first, multiply it by my other power of 10, 10 to the negative 12. So remember, we're keeping our base, and then we're adding our exponents. Negative 12 plus 1 gives me negative 11. All right. If those confuse you, stop, rewind, watch them again, go through the examples a little slower as you go. But the important thing to remember there is the properties really make a difference. You need to remember your properties because then you can know how to manipulate your numbers in a way that doesn't change your answers. All right. We're going to look at another operation as well. That was multiplication. Now I want to look at how to divide with scientific notation. All right, so I've given you an example here, 9.9 times 10 to the 8th divided by 11. So basically what we can do, because these are inverse operations, is I can kind of pick the order I want to do them in. So what I'm going to do is I'm going to divide that first number by the number in the denominator. So I'm going to take the 9.9, I'm going to divide that by 11, which gave me my 0.9. Ideally, I'm taking this and I'm rewriting it this way. All right? These are equivalent. I can do that. It works in math. And this is why you need to learn your properties and understand how your operations work, how you can do and undo them, because then you can figure out other ways to write things, and it will give you an idea of how to solve things. So if I do that, I wind up with 0.9 or 9/10. Well, this is not in scientific notation, so now I want to rewrite it in scientific notation. So what you'll notice, I have 0.9. I need it to be between 1 and 10. 0.9 is less than 1, so I can't use it. So what I'm doing is I'm moving the decimal over one spot, and what you'll notice is this is 10 to the negative first. Why? Because 9 is getting smaller. Okay, again, remember, you can rewatch the earlier videos about writing scientific notation. Remembering which way your decimals go will help you out here. So 9 times 10 to the negative first. Then from there, almost dropped the board, sorry guys. From there, then we're going to, again, multiply our powers of 10 now. So I have 10 to the 8th, which was my original number. Now I'm going to multiply it by that 10 to the negative first that I got. So we keep our base. 8 plus negative 1 gives me a 7. So I'm going to write my answer as the product of two numbers or keep it in scientific notation. So I wind up with 9 times 10 to the 7. So again, we'll take a look at a couple of examples here, and we'll try it. And again, I'm going to use my handy-dandy calculator as well. So remember, the first thing I want to do is I want to divide my first two factors. So I've got 3.6 divided by 120. When I do that division, I get 0.03. 0.03 is not in proper scientific notation, so what we're going to have to do is write it into scientific notation. So ideally what we've done is we're ignoring this number right now. We're going to come back to that one. So how am I going to write this in scientific notation? Well, I need to move my decimal over here and give it 3. It's 3 times 10 to the negative second. Why is my exponent negative? Well, I have a 3. My original number was smaller. My 3 is getting smaller, so that means it needs to be a negative exponent. Again, don't forget to, don't feel bad if you have to go back and rewatch the other video. That's why they're there. You can watch them as many times as you need to. Now I'm going to take my other power of 10, and using my associative property tells me I can combine those two as well. So my base stays the same. I add my exponent, negative 4 plus negative 2 gives me negative 6. So my answer is 3 times 10 to the negative 6. Just a little quicker than putting it into standard form, doing your division, and going on from there. So again here, remember, I'm going to divide my first two factors first. So 6 divided by 240. My handy-dandy calculator tells me that it is 0.025, which is not in scientific notation, so let's write it in scientific notation. I would have to move my decimal between the 2 and the 5. I moved my decimal 2 spots, and 2.5 is actually started as a smaller number. It's getting smaller, so it's a negative 2 exponent. Then I want to take my original power of 10 and multiply those two. So I've got 10 to the negative second times 10 to the negative second. I keep my base. Negative 2 plus negative 2 is negative 4. So my answer is 2.5 times 10 to the negative 4. And I'm going to grab my handy-dandy calculator here to help me out on this one. So we're going to divide our first two numbers. 4.608 divided by 0.96 gives me 4.8. 4.8 is already between 1 and 10, so I don't need to adjust it at all, which means I'm just going to take my exponent times 10 to the negative 22nd and write it down here in my answer. That is my factor, 4.8 times 10 to the negative 22nd, still in scientific notation. Again, let's look at our first two numbers. I've got 9.9. I want to divide it by 9,900, which gives me 0.001. So remember, in scientific notation, our first number can be equal to or greater than 1. So in this case, it's going to become equal to 1. 1, 2, 3. I had to move it 3 places. So it's 1 times 10 to the negative third. Why negative? Because the 1 is getting smaller. Okay. Then we're going to take our original power of 10. We're going to combine our two powers of 10. So I've got 10 to the negative third times 10 to the 20th, which leaves me with 1 times 10 to the 17th power. All right. So really, you just want to break it down. And again, when you're trying the problems, make sure you're writing your work out, because if you try to keep too much in your head, that's where we tend to make mistakes. So make sure you're writing it out and you're following it step by step, and that you're not leaving anything out. Again, if you have questions, you know where to leave them. Have a great night, and I'll see you guys tomorrow.